Welcome back to Refactoring Paleo Rose, where we take a 20-year-old Mac app and modernize it. My name is Tom. One of the things I really need to do is fix our document storage. Now, this is likely going to take place over many episodes because we have a very complex problem going on. You may remember that we have a document file format that is SQLite based right now. We did have some other formats that were older that were XML based, for example, but I've decided not to support those anymore. But I have to support something, so we have the latest version of the file format, which is SQLite. There's nothing wrong with SQLite in and of itself, but my implementation of that is something to be desired, so we need a new file format sometime in the future. But not right now, because we need documents to work for the application to work. So we have this problem that file storage is not working properly. So what are the symptoms that we have right now? And the symptoms are quite obvious. We can't read the files correctly, and we can't write the files at all right now. So when we read the data, there's a good chance we're actually pulling in the data, but it's not actually appearing as we'd expect in the UI. And that's a problem. We want it to be able to appear in the UI so we see what's going on with the data in the app, and that's the whole point, is to see the data presented to the user. So it doesn't seem to be working. We don't see the layers as we expect. We don't see them set up properly. We don't see the tables or data sets either. So we got something going on there. The other problem is we can't write the files anymore. Something is broken. And when we do save, we start seeing errors in the log. Neither of these things are good for right now. We want to move on and get all this stuff fixed. So what exactly is the problem? Well, part of the problem is that there's not one problem. It is many problems altogether. The first problem is I've been working on slowly a new system to read and write our data to the memory store, with the goal eventually just to get rid of the memory store altogether. We don't really need it anymore. But right now we still have it. We still need it. So as a result, we have to support it. But all this code I've written for the memory store isn't actually fully integrated with the rest of the app. And that's causing two basic problems. One is there's no single source of the truth. So we have one way of getting the data, trying to influence how the app appears, and we have another way of getting the data that's trying to influence the way these things appear. And in some cases, these are actively working against each other. Now, this one is totally me today. I should not have integrated it when I did, but I wanted to make sure it's kind of working, and now I'm suffering the consequences of that. Another issue is I've noticed some weirdness going on in SQLite, so I added a few other little restrictions on how SQLite is read and written, and that's actually caused part of the problem with saving files and breaking the files as they save. But ultimately, when it comes to reading and writing the memory store, there is too much old code directly accessing the memory store. Nobody should be accessing directly the memory store, especially the SQL part of the memory store, except for the class that we have specifically for doing that. All this other code that's all over the app is reading and writing into the memory store, and none of the rest of the new code can keep track of it because it's just updating things in unexpected ways. So we have a big job here to fix all this. So it's not going to happen in a single episode. It's going to probably take many episodes to fix. So let's get a sense of how much SQL is actually scattered throughout the app. Well, here we are. We're in Xcode 26, and we have our project open. Let's just look for SQLite in here. Look at all these SQLite calls. Some of them are managed to survive crossing over from Objective-C to Swift. Some of them are still Objective-C. But the only place that really should have SQLite calls is the in-memory store. This particular class right here. Its job is to manage the in-memory store. But we have lots and lots of SQLite calls. What this means is all sorts of updates can happen at any time to the in-memory store, and they can conflict with each other. And that's exactly what we don't want. So that's job number one. Well, I should say it is a major job. The second major job is to deal with this single source of truth problem. The single source of truth is really meant to be the document model. So this type is meant to manage the tables, the data sets, and the layers. Those several items are meant to be managed here. Now, right now, they're being stored as simple arrays, as you can see, but eventually they may have to go into custom managers that manage all of these things to get more fine-grained control. So they're not just arrays. But as of right now, this document model is what's actually talking to the in-memory store, sending information to the in-memory store and getting data out of the in-memory store. Other parts of the app are not using these things. They're accessing the in-memory store directly and coming up with their own list of table names and their own list of data sets and so forth. What on earth to do? Well, there's nothing simple about this. I spent several days just trying to decide how to go about doing this. And it's not easy. The code is too deeply ingrained into the Objective-C code and the old code. And this is exactly one of the reasons why I thought about doing a project like this, is because pulling this out is difficult. And making it clean is what, cleaner is what we really want to get to. Let's take a look at a few things really quickly. In the document model, we have this method here. This method or function is meant to get the memory store pointer out of the memory store so the Objective-C can use it. So one thing we could do is do a quick build. Give it a moment. Okay, we have the build. Now we can filter out our warnings to see where exactly we're calling this method, which is deprecated, is showing up here. So we can take a look at this list of deprecations and get an idea where they're coming from. I would also point out these deprecations are also the same thing, more or less. So we can see it in the document. We're reading and writing by getting the pointer and passing it to the table controller. That pointer going to the table controller is actually going through a sequence of things to write out data to the in-memory store directly. And right immediately following it, we're telling the document model to do the saving to file. This sounds like it's okay. It's updating all the layers, sending it to the in-memory store, then writing it to file. But the problem is there's also hidden in there additional writing to that SQLite store. So these things conflict. We're doing things where we're changing the behavior when we awake from nib, making sure that we can pull data from the database. Here we're just checking to make sure we have a store. At this point, our document model will always have a store one way or the other. So we probably don't even need to make this check anymore. And then we started getting into much more complicated things where we're making controllers these based off of different data sets. That's a problem. We also have this strange function in here that is doing some mathematical calculations, but it's basically getting it all from the SQLite store directly. And that doesn't seem like a good use of SQLite store. So that's something we need to move. We also have a table importer. The object of this table importer is to read a text file, format it, and get it into the SQL database. Now, this actually kind of makes sense that this table importer isn't directly integrated with directly talking to the document model. But we still need to import the data and send the data to the document model / in memory store to update it that way instead of directly reading it into the database. This seems like a little bit more manageable. There's a lot of places that once you have the memory store, it's going to pass that along. So anywhere you have a function that's called or a method called save to SQLite database is going to be a problem. So there's a lot of them. So I think the first thing I'm going to do is just disable all these save to SQLite database methods. So this should be relatively easy. Whether or not it's a good idea or not, we're just going to comment out the code so it doesn't do anything. Okay, so every method call saved to SQL database has been disabled. I mean, the calls are still there, except for one place, but they've all been disabled otherwise. It doesn't mean we disabled everything, but we've disabled a significant amount of code. So what I might want to do here is just see if we get into this code at all still. Now, I disabled that one call at a higher level. It calls down through all this stuff. I have a suspicion that we've now disabled all of this. Let's run the app. Okay, so we're actually pulling a document that already exists when we run this thing. So it has part of the data correct. I'm going to save as. I'm just going to call this test. Okay, we hit no breakpoints. Some of it we wouldn't. We're getting some errors in here, but I'm not entirely sure it's the reason for it. But I'm fairly certain we've already done enough to disable these methods. Again, problematic still, but we're just going to go ahead and remove all these methods that we were just cleaning up. So let's look for anything we've modified. Let's go ahead and get rid of that. And get rid of this. Okay, so now we removed all that code and relaunched the app. We can see the document looks exactly the same as it did before. We have this particular style set up for the document, and it looks the same. By us getting rid of all that code made no difference, because in the end, the new code is taking over the saving roles that we just deleted from the old code. The problem again is that single source of truth. Much of the UI is using the old sources of truth, whereas we have a new source of truth that we need to integrate. So this is only one part of it. This is just saving. If you look at it, it's primarily just saving the layer. So let's run tests and make sure we didn't break anything. Because mainly the code's largely broken anyway. But we'll make sure the tests aren't broken. Test pass. So at this point, I'm going to go ahead and stop for this episode, because now we have to evaluate what we're going to do next. We got rid of a lot of code, which is a good thing. But now we still have SQLite code hidden in here. We have the table importer. We have this make dataset controller, which is a way to create a new dataset for you to plot your data. Again, a make dataset controller. So we have a number of things here, and datasets as well, that are integrated. The datasets and the controllers are deeply integrated types, and they all are reading data from SQLite store and doing various things. So that's going to be a bigger job, is to fix the data sets. It looks like I might have some straggler files where we have two. We have the Objective-C implementation still and the Swift implementation, which probably isn't turned on. So for example, this is one that AI created a Swift version for me, but I have not integrated it. I might want to consider just deleting that for now. But the data set is really kind of a deeply integrated thing to work with the in-memory store. We're going to have to really think about how to fix this, because it is critical. We have to be able to bring in data sets externally and then convert them into data sets. So this is going to be a much bigger job. But we've gotten rid of a significant portion of the code here that shouldn't be doing anything with SQLite. Our store needs it, but we still have a few other places. Even the layer still has access to it. Has a save color method on here. We still need to get rid of these things, but I'm going to hold off until I have a better idea whether we're even calling these things or not. So we have a big job on our plate. We got tentative toe in the water to get things fixed. So we'll do something more along these lines next time. Thanks for coming. I hope you enjoyed this. Feel free to leave me a comment in the comment section. And until next time, my name's Tom.